Hi, today I wanted to talk about the Boeing 737 MAX and the two crashes that have happened in the past 6 months. The most recent one is the Ethiopian ET-302, and then the one that happened 5 months ago with Lion Air was JT-610. Okay, so the purpose of this video is to kind of understand there's a lot of stuff in the media. What are they talking about? There's a lot of jargon, there's a lot of definitions, a lot of terms been thrown around here and there. So I thought I'll put this video together and try and kind of understand that, get some of your feedback too. Any comments, feel free to comment, any kind of correction that you have, any kind of facts. I'm not going to get too technical in this video because I just want to keep it simple for everyone to understand. Okay, so the MAX 737 came out in 2016. Now, I don't have all the facts. Wikipedia is a great source, but to my understanding, there's 8 and 9, MAX 8, MAX 9, which are being used by about 383 of them are in circulation in the world. So many airlines have them. What happened last week? They were grounded. That's about around the second week or third week, second week of March, they were grounded. Right after the accident, March 10, they were grounded by different airlines all over the world. The most recent being FAA grounding them in the US and then Canada too. Now, what is the 737 MAX? Let's try and understand what that is. 737 MAX is the next aircraft model that Boeing made after the NG, or next generation, which are 737-700s, 800s, 900s. So this is a next version. This airplane, because it's the next version, it's also larger, it has more range, it has powerful engines. So what happened is that Boeing added LEAP 1B engines. They call them LEAP 1B. I'm not going to go into the kilonewton thrust that they have, but they are bigger. The fan blade in the front is bigger. What happens is that once you build such a thing, they want to keep the signature of this airplane, of the 737, the same as the other model. Why? Because airlines would prefer that. You don't want a huge plane coming in called 737 that won't fit in the gate anymore. So they want to have the same profile, okay? Now, how do you fit powerful engines which have a big diameter of the fan in the front, right? So what they did was, according to what I understand, they plugged these engines further in the front and higher up, okay? So that they don't hit the ground. There is, I think, 18 inches of clearance between the engine base and the ground, okay? So this is what the story is. This is how the MAX was built. Let me show you a model that I built over here first, okay? Now, based on, right here, so based on the stories so far, I was inspired to build this airplane model. Let's take a look at this right here. Look at that. We have the winglets, we have the engines that are forward, then we have the wheel wells, okay? I tried my best, okay, to make it like the original. There's this dorsal fin, that's the fin, horizontal stabilizers, okay. So in the MAX aircraft, the engines were placed further in the front and slightly higher too. Okay, so that there's much more clearance. There's a lot of clearance between the ground and the engine. So let's talk about the MCAS system. It's called the Maneuvering Characteristics Augmentation System, and it takes inputs from the airspeed and angle of attack of a plane and tries to make a correction to the horizontal stabilizer so that the nose can pitch down and get the aircraft out of a dangerous situation. When does the MCAS engage? It does this at low speeds in a clean configuration. What does clean configuration mean? When a plane is taking off, you've noticed how the flaps come out, okay? So that's when you extend certain amount of flaps for takeoff and certain amount for landing. Takeoff flaps are less than the landing flaps because you want to be much slower in a landing. So the MCAS system will engage only if the flaps are up, or what they call a clean configuration, okay? Flaps are up, airplane is slow. Per my understanding, the MCAS system does this without any input from the pilot. It does this automatically. And from what I understand, a lot of pilots did not even know this system existed, although they do say that there are switches that can disengage the MCAS. Okay. So in this aircraft, this horizontal stabilizer right here, as you can see, this can be pitched up and down. Okay, this can be pitched up and down. The elevators, this one and this one, these can be pitched up and down using the pilot control or the yoke. But the entire horizontal stabilizer that you see over here, that gets activated by a Jackscrew. This cannot be manually moved up and down by the pilot. So the MCAS system takes care of moving this bigger surface right over here, while the pilot uses the yoke to move the smaller surface. So that is something to note. So why did the 737 MAX 8 aircraft or 9, why did they need the MCAS system? Well, the engines on this plane are a lot bigger, so they were placed in the front, right? Further out, okay? That creates a natural moment for the nose to go up, okay? Because of which the MCAS system tries to negate that by giving a negative input or giving an input for nose down. That's all we know at this point, what the MCAS does. MCAS gives input to an electric motor which is connected to the jack screw at the back to move this surface up and down, right here. This surface. Now let's get back to Lion Air JT610. This flight took off from Indonesia, if I'm not mistaken. There was 189 passengers, including crew. It crashed in the ocean, okay? The facts that we know about Lion Air is that, it was having control issues right after it took off, okay? And it certainly went up, it certainly went down, and then, there was a lack of control, and then finally it plunged. So once the plane's going up, the AOA is the angle of attack. That means this angle, pretty much. How much did it pitch up, okay? There's a lot of technical detail that explains that, the line joining the leading edge to the trailing edge with the horizontal. But we're trying to see that if the wind's coming in from here, how many degrees did it pitch up? How do you detect that? So right here, this is what it may have looked like. Essentially what this does is when the plane is taking off, when the plane is pitching up like that, this stays in the direction of the opposite wind. So it's like a wind vane, and it stays parallel to the wind. So it can give us an angle of the pitch up. In this case, for Lion Air, it may have looked something like this, okay? As you can see right here, something like this. Because of this, an input was sent to the computer. So it started giving inputs to the horizontal stabilizer right here. This is the horizontal stabilizer to put the nose down, okay? But the nose may have already been down, or it may have been sufficiently down. We don't know that. But because of that, it kind of plunged down and went down. They say that the pilots tried to fight that, okay? So what they have done is they probably used the yoke to pull back, okay, to lift the nose up. We don't know. We have to still wait for the results of the investigation. But this is the kind of understanding I have. This is what I'm trying to explain, that you have the AOA indicator and how it may have interacted with the horizontal stabilizer right here, okay? Now, something to note is that the horizontal stabilizer moves up and down, okay? And so does the elevator right over here. Now, in the Ethiopian Airline crash, which is the ET302, what happened is that, as I explained earlier about Lion Air crash, the AOA, or angle of attack indicator, is like a sensor or transducer which gives input to the MCAS system, per my understanding. The MCAS system then lifts up or down this entire horizontal stabilizer so that it pitches the nose up or down. One thing that the FAA noted that they found in the wreckage of the Ethiopian air crash was that the mechanism that moves the horizontal stabilizer up and down was set in a full nose down position. That is the jack screw, okay? So the jack screw is essentially a screw that rotates in such a manner that this is going to go up and down. I have made a small model of the jack screw and I've tried to explain how it may have worked and how it may pitch the horizontal stabilizer up and down. One thing to note is that if the horizontal stabilizer is in such a position where the nose is down, no matter how much you fight with the elevators, I don't think it's going to be a win, because this surface is much bigger. It's going to have a lot more moment to put the nose down. So that is one challenge I think that must have happened in that airplane, but that's all speculation. So as we get more and more facts, I would like to update and talk more about it. If you have any comments, any kind of corrections, anything you feel free to comment over here. This is the best I can do, trying to explain it to everybody. So I hope that helps. So thanks a lot. Please subscribe to my channel and hit the like button. I'll see you next time.